Academy, let's crack it. In this video, we are going to discuss the volume integral from its basics and calculus, engineering mathematics, calculus. In the calculus chapter, volume integral will be discussed from its basics. Before moving into the topic, I will explain the few details on the test, Unacademy compact test. Yes, Unacademy compact. So the weekly scholarship test will be conducted in the Unacademy platform. July 4th already over, and the next compact, it's an Unacademy mega compact, right? It's a mega compact, Unacademy mega compact from the Unacademy platform, right? So here here India's weekly competition for preparation in 60 minutes. Within the 60 minutes, challenging and original GATE questions curated by the best educator in the platform. Use the code Moorthy536 to avail the benefits in the platform. Take it live to compete with the best. Super fast and fun with the All India leaderboard, and identify and improve your weak areas through the detailed video solutions. Detailed video solutions will be provided for the students, right? Is it clear? Yeah, very good, very good. Yeah, detailed video solutions will be provided. And compact test, after completing the mega compact test, so you are going to get the next compact test 18th and 25th. 18th and 25th also you are going to get. The test is starting at 11 a.m. So 60 minutes, completely 60 minutes. So try to attend all the compacts to get the benefits. And if you secure the compact test, I will explain the compact details. 11th July, so coming Sunday 11 a.m. it's GATE and ESE mega compact test. You are going to get the mega compact test scholarship from the pool of 4 crore rupees. Okay, completely 4 rupees plus you are going to get. And if you secure the rank from 1 to 3 in the Unacademy compact on 11, you can get the 1 year free GATE and ESE plus subscription. And if you secure the rank from 4 to 10, 75% scholarship on the subscription charge, and 11 to 50, 50% scholarship, and 51 to 100 rankers, so the GATE and ESE category. Here, and apart from the lucky participants, 500 lucky participants will stand a chance to win surprise gifts, the digital watch and its tablet and JBL speaker, as well as Amazon gift vouchers. So these are the benefits you can avail for the 500 lucky winners. You also one among them, among the 500 lucky winners, right? Or you can avail the GATE and ESE subscriptions. Use the code Moorthy536 to enroll into the Unacademy mega compact test on coming Sunday. Here already the June 16th batch were started. Spark for GATE 2022 and Wave for GATE 2023, completely mechanical engineering English batches, right? It's completely English course. So Praveen Kulkarni sir, Devendra Singh Negi sir, and Vehanandan sir and myself, we four together handling the complete course. So use the code Moorthy536 and use the code Moorthy5, right? Now we are moving to the topics. Today's topic, GATE, engineering mathematics, calculus, volume integrals we are moving, right? So in the volume integrals, in the previous video we have completed the area integrals. Now the same kind of thing, now we are moving into the volume integral. Coming to volume integral, now the area integral in the previous video, so you can refer from the area integral part 1 as well as part 2. Area integral, the formula for the area integral, area is equal to integral of A to B, it's y into dx, or or the area is equal to integral of a to b x into dy. So these are the formulas for area. The same kind of things we are using for the volume integral also. So coming to the volume integral, let y is equal to f of x be the given curve. The volume of the solid obtained by, so how we are applying the volume? The given solid is obtained by revolving the curvature. The volume for the given curvature is obtained by revolving the given curve completely about the particular given axis. It may be an y axis or it may be an x axis, while revolving the given curvature about the x axis. So this is the formula to identify the volume integral. And yes, volume is equal to integral of a to b pi into y square into dx. Pi into y square into dx. Now the value pi into y square. Now the limit a and b are the x-axis limit. So what we are doing here, look at this condition. It's a graph and x is equal to a and up to the x is equal to b. So this is the given curvature. Y is equal to f of x. So we are revolving this curvature about the x-axis. So we need to identify the x-axis limit. So the x-axis limit may be given in the question, or we need to identify by substituting the other variable is equal to 0. It's pi y square. Here area, it's y into difference. We are multiplying pi as well as the y square. Similarly, the volume of the solid obtained by revolving the curvatures, x is equal to y of x. Sorry, x is equal to f of y about the y axis. Now the given curvature x is equal to f of y is revolving the y axis. While revolving the given conditions about the y-axis, what we are getting here, it's a limit CD, and volume of the given solid, now it's a c to d pi into x square into dy, and here x into dy, here pi again x square, pi into x square. So this is the condition, right? Now I'm going to give you two example problems followed by the few previous. Find the volume of the solid by rotating the area bounded by the curvature y is equal to x cube. So what we are doing, the given curvature is revolved about the some axis. Here it's x axis, and the ordinate x is equal to 0 as well as x is equal to 2. So directly they have given the value of limit as well as y value. The only thing, so we need to substitute, it's a type 1. Type 1 is the direct substitution. Now the volume formula, we are aware of it. It's a 0 to integral of a to b pi into y square into dx. Here y is equal to root of x cube. Y square is equal to, and what about the value of y square? Now y square is equal to x cube. While squaring it, root can 2 pi into x cube into dx. Now integrate the given x cube with respect to x. X power 4 divided by 4. Pi into x power 4 divided by 4. The limit, it's a 0 to 2. While substituting the value, pi into 16 divided by 4, that is 4 pi cubic units. 4 pi cubic units is the right answer. Okay. Okay, next one. Next one, the volume. The one more thing. Actually, the volume of the cone, we are aware of it. It's pi r square h divided by 3. So here, but I am giving the some solutions with volume formula, volume integration formula. Now the volume of the cone, we are aware of it. Its volume of the cone is equal to V is equal to pi r square h divided by 3. This is the formula. So we are going to derive this formula through the volume integral. Now height of the cone is h, radius is equal to r by the integration. So we can use any one of the format. Okay, either x-axis or it may be an y-axis, right? Now we have to reduce the line OA. So what we have to do? So we have to reduce the, we have to revolve the line OA. So here the revolving. So how we are revolving, I will explain it. In case if you are having any doubt while I am explaining it, so kindly ping your doubt immediately in the live chat box. Okay. So the complete in next video onwards we are going to start the vector calculus. Vector calculus also will be discussed from its basics. So I'm handling complete engineering mathematics for the aspirants in the platform, so you can get the complete support. Now it's 0 to A. Now 0, 0, it's 0 to a. Now I'm going to take it as the radius. So now I'm taking the axis of the cone along the x-axis. Either it may be along the x-axis or y-axis. So we can consider in any one of the axis. So here I am considering it as along the axis. Therefore 0 to here. Now the x limit varies from 0 to h. Now radius is equal to r. Therefore y-axis limit it varies from 0 to r. Right. Now take the any one of the generator. The end line is called as generator of the cone. Now here 0. Here it's a 0 comma 0. This peak point a. It's a h comma r. Okay. Now the x-axis limit it's a 0 to h. Y-axis limit it's a 0 to r. Now the equation for the straight line. This line straight line is revolved about the x-axis, but the point O fixed to 1, only A it follows the circular path. So while revolving this line about the circular path, we are getting the cone. Now the straight line equation, x minus x1 divided by x2 minus x1, it's equal to y minus y1 divided by y2 minus y1. So this is the x-axis, right? We are going to take it is in the x-axis. Now x minus x1 0 divided by x2. x2 is equal to h. There are 2 points are there. Here x1 is equal to 0 comma 0. This point belongs to the h comma 0. h comma 0, right? Therefore the value 0 comma 0 to yes h comma 0. It's a value. Here it's x1, right? We have to consider h comma r. The end points we need to identify, right? The x1 comma x2, x2 comma y2. I'm going to give the x1 comma x2. The x1 comma y1 is equal to 0 comma 0. The point O. Now x2 comma y2. x2 comma y2 is equal to, it's a h comma r. So this is the condition, right? It's a h. Now substitute the values. While substituting the value, x1 is equal to 0. Here x1 is equal to 0 divided by h minus 0, that is x1. x2 is equal to h. Then y minus 0. Now the y1 value is equal to 0. y1 value is equal to 0. Now the y2 is equal to r minus 0. What we require, if you are revolving the given curvature about the x-axis, the formula is integral of 0 to a to b pi y square into dx. We require the value of y. From this equation identify the y. Y is equal to rx divided by h. Y is equal to rx divided by h. Now substitute y square is equal to r square x square divided by h square into dx. While integrating the given function with respect to x, r square and h square constant, pi r square divided by h square. Now the x square is integrated with respect to x, therefore it's x cube divided by 3. Is it clear now? So we are considering it's x cube divided by 3. Okay, divided by pi r square h divided by 3. And if you substitute the limit, so here we need to substitute the upper and lower limit. Upper limit, here it's h, lower limit 0. If you substitute it, pi r square divided by h square, and now it's h cube divided by 3 minus 0. So this is what we are getting, right? So now the final volume of the cone we are getting. Either we can consider the height of the cone along the x-axis, or it may be an y-axis. If you consider along the y-axis, again the same answer we are getting, right? So I am giving the next question. One more example to you. Now find the volume of the solid revolution. Okay, find the volume of the solid revolution generated by revolving about x-axis. Okay, the regions in the first quadrant bounded by 4x square plus 9y square is equal to 36. So what they are asking, it's an ellipse axis. Ellipse axis. Only the region bounded by the first quadrant. Only the first quadrant is revolved about the x-axis. While revolving the first quadrant above the x-axis, and what will be the solution? So we are aware of it actually. So this is the entire ellipse portion. So this is the entire ellipse portion, right? Okay, fine. It's an entire ellipse portion. Now, what we are doing, only the first quadrant. The question itself they have mentioned the region in the first quadrant, and it is revolved, right? Only the first quadrant of the ellipse. It's an ellipse equation. So what about the ellipse equation? Ellipse equation is equal to it's x square divided by a square plus y square divided by b square is equal to 1. So this is the ellipse equation. Now this ellipse equation is converted, right? Now take this 36 into the denominator, LHS side denominator, then it satisfies the ellipse equation. Only the first are taking the value from it's a 0 to 3. They are not mentioning the first quadrant. In case you are taking the whole length, first and second quadrant, while we are going to revolve any one quadrant or any two quadrant about the x-axis, first and second or third and fourth, right? In case if you want to revolve about the y-axis, then we need to take the value, yes, the first and fourth quadrant, we need to take. So here the question itself they have mentioned the first quadrant, so I am considering the limit as first quadrant. It's a 0 to 3. They are not mentioning anything regarding this point, so we need to take the value from minus 3 to, actually it's a minus 3, 0, it's plus 3, minus 3 comma 0, here it's 0 comma 0, yes, 3 comma 0, right? Square divided by 3 square plus y square divided by 2 square is equal to 1. It's an equation. It's an ellipse equation. Now the volume. So what we require here, so while revolving the condition, the limit, here the first quadrant they have mentioned. So the volume equation I am going to give you. What about the volume equation here? Yes, volume is equal to pi y square into dx, right? So here a to b, if they are not mentioning specifically first quadrant, so we can take the minus 3 to plus 3. But the question is, so the first quadrant, the limit, it should be 0 to 3, pi into y square into dx. Equation, we are going to identify the value of y square from the ellipse equation. Now the ellipse equation, x square, 4x square plus 9y square is equal to 36. It's a condition. Now y square is equal to 36 minus 4x square divided by 9. Okay. Okay, fine. Now the y square is equal to 36 minus 4x square divided by 9. The volume is equal to, now it's a 0 to 3 pi y square into dx. Now the y square value, it will be substituted directly into the equation. It's pi into 0 to 3, 36 minus 4x square divided by 9 into dx. Pi by 9 into 36x. Now integrate with respect to x. Now it's 9 is taken. 4x square integration equal to 4x cube divided by 3. Now substitute the upper limit. And if you substitute the upper limit, what we are getting? 36 into 3 is equal to, yes, 36 into 3. It's 108. Right? 108 minus, it's 27 into 4. Right? While taking the LCM, what we are getting here? 324 minus 108 divided by 3. So this is the condition. And if you separate it finally, 8 cubic unit. 8 by cubic unit. So this is what we are getting. Now we are going to discuss few previous year questions so you can get some clarification. The first question, it's a mechanical engineering 2010 1 mark question. So what they are asking, the parabolic arc y is equal to root of x, the limit 1 less than or equal to x less than or equal to 2 is revolved around the x-axis. It is revolved around the x-axis. Revolution is the volume of the solid of revolution is. So what will be the volume of this solid? So now I am giving the solution. Listen. Now the volume, formula for the volume. So we are revolving about the x-axis. So the value is a to b pi into y square into dx. With respect to dx we need to do. So what about the value of y square here? Y square is equal to root of x the whole square is equal to, it's x. The limit varies from 1 to 2. Now substitute the limit 1 to 2 pi into x into dx. While integrating it, it's equal to pi into x square divided by 2 upper limit 2 lower limit 1, right? It's equal to pi into, so we need to substitute the value, and if you substitute the value, what we are getting here, it's 2. Yes, 4 divided by 2 is equal to 2 minus 1 divided by 2. 2 minus 1 divided by 2 is equal to, so what will be the value? It's equal to pi into 3 divided by 2. Pi into 3 divided by 2. It's option D. Option D is the right one. 3 pi by 2 is the solution for this question. It's a repeatedly coming methodology, right? Next one. Now, the one more question, the mechanical engineering 2019 set 1 question. The parabola x is equal to y square. Parabola x is equal to y square with 0 less than or equal to x less than or equal to 1 is shown in the figure. The volume of the solid of rotation obtained by rotating the shaded area by 360 around the x-axis. So here also we are revolving around the x-axis. It's the volume formula, the same formula we are going to use. Now the volume is equal to integral a to b pi into y square into dx. Pi into y square into dx, right? Yes. Now I am giving the value. Listen. Yes, the limit, it's a 0 to 1 pi into, what about the value of y square? Y square equal to x into dx. Same as like about the previous problem. Pi into, it's x square divided by 2. Now substitute the upper limit 1, lower limit 0. It's equal to pi into 1 divided by 2. The solution is equal to, it's a pi divided by 2. Pi divided by 2 is the solution. It's A. Here option A is the right one. Okay, is it clear now? Okay, fine. Next one. So the volume generated by revolving the area bounded by the parabola y square is equal to the y-axis. So here it is revolved about. The volume is generated by revolving the area bounded by the parabola and the line about the y. What we require here? We require the value of y-axis limits. We require the value of y-axis limit. Now there are two. One is parabola, another one is line. X is equal to 2. Right? It's revolved about the y-axis. And if you draw the graph, yes, it's a graph. It's x is equal to 2. It's an y square is equal to 8x. While revolving about the y-axis, we require the limit. So we require this limit plus 2 minus y. Plus 2 minus y. So volume we can take, it's integral of a to b pi into the value we need to substitute. While substituting the value, what about the value here? Yes, it's x1 square minus x2 square into dy. So this is what we need to substitute. In terms of y, we need to substitute. In terms of y, we need to substitute. Now the condition I am going to give you. Now substitute x is equal to 2 into the equation. What we are getting? And if you substitute x is equal to 2, y square is equal to 8 into 2 is equal to 16. Now y it varies from minus 4 to, yes, it's a plus 4. Is it clear now? Guys, is there any doubt up to this point? Next one. So coming to this limit, now the volume, it's equal to integral of minus 4 to plus 4 pi into x1. So from this equation I am going to take x1 is equal to x1 square we require. X1 square we require. Actually in terms we are going to revolve about the y-axis, and it's y square divided by 8 the whole square. that is y power 4 divided by 64. Now here x2 square is equal to y power 4 divided by 64, y power 4 divided by 64 minus 4 into dy. Now do the integration. So it's a minus to plus, right? So we can write it's 2 into. We can write it's 2 into, it's a 0 to 4 pi into, it's y power 4 divided by 64 minus 4 into dy. And while substituting the value, it's equal to 2 pi. Now the value y power 4 integration is equal to y power 5 divided by, it's 64 into 5, it's 320. Is it clear now? It's a 64 into 5, it's 320 minus 4y. 320 minus 4y. Now substitute, it's 0 to 4, upper limit minus lower limit. While substituting the value, it's 2 pi into, now the value of upper limit minus lower limit we need to substitute. What about the value of 4 power 5 we need to substitute? 4 power 5, I think it's 1024. 1024 divided by 320 minus 16. And if you substitute the lower limit, it's completely 0. It's equal to 2 pi into, now simplify by 4. Now simplify by 4, right? 4, or it may be an, so we can simplify the same equation by 16. It's a 64 divided by it's 20, right? Is it clear? 320 divided by 16, it's 20 minus 16. Yes, the once again we can do the simplification. It's equal to 2 pi, now it's a 16 divided by 5 minus 16. 16 into 4 and 5 into 4 minus 16. Now do the simplification. It's a 64, right? It's equal to 2 pi into 16 minus, it's a 64 divided by 5, right? What about the value? Minus 64 plus 16, it's a 48. Is it clear? What doubt? So here it's a y square. Once again I will explain it. X square is equal to y power 4 divided by 64. Yeah, right. Minus 4 we are giving that. While giving the minus 4, yes, y power 5 divided by 320 minus 4y. Now we need to substitute this value from 0 to 4 because the y is the even function, right? And it's 2